Okay, section 4.4, trig of any angle. So this is letting you know that not every triangle or every coordinate or every trig function is going to land perfectly on one of those magical spots on the unit circle, right? Not everything fits into the unit circle. In fact, only a handful of things actually do, right? So for these ones, we need to keep that in mind. So set up some axes. Read what they tell us. I personally like to use the second piece of information first more often. You'll see why as we do more. So sine of theta is greater than 0. Greater than 0. What does that actually mean? Sine is positive. There are only 2 quadrants where sine is positive, right? So you've got all students take calculus, so the all quadrant, and then obviously the students quadrant. But also, sine is the y value, right? So positive y values. It's got to be up here. If you can see my yellow highlighting at the top, or it can't be down here, however you want to look at it. So I've narrowed it down to 2 possible quadrants. Now I'm going to look at the other piece of information. The other piece of information says cotangent theta is equal to negative 9/7. Well, I don't like reciprocal trig. I don't have those memorized as well, so I always flip it over. So tangent is negative 7/9. All students take calculus. They're all positive in the first quadrant, and this is telling me tangent's negative. So it can't be over here. So now I know exactly which quadrant I am in. I am in this quadrant. I'm going to draw a generic triangle because I don't really know much about this. So I'm going to draw a generic triangle connected to the x-axis at 90 degrees. Theta between the x-axis and the hypotenuse. And I'm going to label it with what I know. Tangent is negative 7/9. Hold off on that negative for a second. Tangent is opposite over adjacent. Now looking at your picture, which one should be negative? Is left negative or is up negative? Hopefully you understand that left is negative. Now that I know those two sides, I can find the hypotenuse. Pythagorean theorem, hypotenuse squared equals side squared plus side squared. Remember, when you square something, it always comes out to be positive. So x is going to equal the square root of 130. I can't do that without a calculator, so that is what I am going to replace the hypotenuse with. I am writing the hypotenuse down. A hypotenuse is always positive, so that side will be labeled square root of 130. Now I've got a triangle and I have to do SOHCAHTOA on it. Sine, opposite over hypotenuse, 7/√130. Is this on the unit circle? If I go left 9, am I still on the unit circle? No. Since this is not a unit circle problem, you do not need to rationalize. That means leave it as 7/√130. 7 times root 130 divided by regular 130 is also correct, but it's a waste of time and space and energy. Cosine, cosine from theta, adjacent over hypotenuse. Tangent from theta, technically one of these was given, might as well fill in the other one as well. Now flip them over to get the reciprocal functions. Cosecant, secant. See if you can do the last one, complementary co-function. If they want cosine of pi over 2 minus theta, that's actually sine of regular theta, which my answers tell me is 7/√130. So a couple things. Do not rationalize if it is not a root 3 or a root 2. If it is not a special triangle, we are not rationalizing it. Pay special attention to where your negatives are going, and then just answer the trig function questions. See if you can set up number 2. Set up some axes. Try to narrow down which quadrant you're in. If you guys get this in the wrong quadrant, it's almost always wrong because you're in the wrong quadrant, so things aren't going good. Theta is between pi over 2 and 3 pi over 2. Well, unit circle, this is pi over 2, this is 3 pi over 2, so it just told me it is not over here because it has to be between those going counterclockwise. So I've narrowed it down to 2 quadrants. The next piece of information says sine is negative 3/5. So again, all students take calculus. So all students take calculus. Here, sine is positive. And this question's saying sine is negative. Also, sine is y values. Y values are not positive up above. Sorry, are positive up above. They are negative down below. So a generic right triangle that touches the x-axis, theta between the hypotenuse and the x-axis. They tell me sine is negative 3 over 5. Sine, opposite over hypotenuse. Which one of those is allowed to be negative? Which one makes sense that it's negative? Hypotenuse is never negative. And when you go down on the y-axis, that is negative. So negative 3 and the 5 is positive. Pythagorean theorem to find x. Hypotenuse squared equals leg squared plus leg squared. It doesn't matter what order you do those. X is going to be 4. You might have just seen that from knowing Pythagorean triples. If I write a 4 where that x is my triangle correct? When you go left, is that positive 4? No, this needs to be negative 4. Your Pythagorean theorem will always give you a positive answer. You have to look at the picture and decide if it should be positive or if it should be negative. Once you get all your sides labeled correctly, bust out your SOHCAHTOA. Sine was actually given. Cosine, tangent, flip them over. Remember, these will not be partnered up for you on test day. And then complementary cofunction of cosecant. Complement of cosecant, drop the co, is just secant. Secant is answered up above. Okay, see what you can do on number 3. I'm going to get mine all set up, and I'm going to get rid of 2 of the quadrants. So what I'm saying is I am going to figure this information out. When you unpause the video, I will have done that much. Okay, that highlighted part said cosine theta is greater than 0. Greater than 0 is a fancy way of saying cosine is positive. I wrote my all students take calculus. All of them are positive in quadrant 1. Calculus, cosine is positive in quadrant 4. Or cosine is the x value. X's are positive to the right. So I've got it narrowed down to 2 quadrants. See if you can use that last piece of information and figure out exactly which quadrant this is in. So tangent is negative 7/5. Well, they're all positive in the top corner, so it must be in quadrant 4. Generic right triangle, touching the x-axis. Theta between the x-axis and the hypotenuse. Tangent, opposite over adjacent. Leave the negative out for a second. Opposite over adjacent. Which one should be negative? When you go right on the x-axis, that's positive. When you go down on the y-axis, that's negative. Pythagorean theorem to find x. Hypotenuse squared. Everything squared comes out positive. Square root of 74. I'm writing it on the hypotenuse. Should it be positive or negative? Hypotenuse is always positive. Fill out your SOHCAHTOAs. Do this whole thing. I'm going to pause it, and when you unpause it, you will see all the answers. So pause your video. Okay, check your answers. Also, you should be able to match up. You're in quadrant 4. In quadrant 4, all students take calculus. Only cosine and its reciprocal should be positive. All your other answers should be negative, so just something to keep an eye on. See if you can set up number 4. Where is pi? On the unit circle, pi is over here. So the point is right here. So it doesn't even make a triangle, right? If you land on the axes, it is not a triangle. It's a point on the unit circle. Left 1, up 0. Knowing that, can you fill out your sine, cosine, tangent? Cosine, comma, sine. So sine is 0, cosine is negative 1. Tangent is y over x, 0. Flip them over. When you flip over 0, remember, here's the example right here. I'm going to circle it in red. 0 is technically, well, not negative 1. Let me write it in red. 0 is technically 0 over 1. When you flip that over, you get 1 over 0. Not equals, but when I flip it, I get 1 over 0. 1 over 0 is undefined. So when you flip over 0, it's reciprocal, undefined. When you flip over -1, it's still -1. When you flip over 0, undefined. Cosine, complementary co-function of cosine, regular sign is 0. So sometimes they do land on the unit circle, right? So you want to keep an eye out for that. Try number 5. I see over 3, pi over 3. That one is going to land on the unit circle. See if you can draw it correctly. Okay, so it was more than one trip around, right? So you might want to subtract a full circle to find out what a normal trip would be. So minus 2 pi, which is 6 pi over 3, brought me to 10 pi over 3. Still more than one trip around the circle. Minus 2 pi again brought me to 4 pi over 3. The pi over 3's hug the y-axis. This is 4 pi over 3. Can you figure out the coordinates if it's at 4 pi over 3 in quadrant 3 hugging the y-axis? So it went left just a little bit. A little bit is -1/2. Left is negative, and a little bit is a half. It went down a lot. When it hugs the y-axis, that's almost your biggest y value, right? So down, -√3 over 2. Cosine, sine. See how many you can figure out. Tangent, sine over cosine, or y over x. See if you can figure out the whole right-hand side, including that cotangent one. Okay, so hopefully you knew sine was y, cosine was x. For tangent, I went ahead and showed my work. But remember the shortcut I showed you a video or two ago? Tangent of anything pi over 3, right? We are at 4 pi over 3. Should have 1 3 in it. So just the pi over 3 answer. And then based on my slope, this is clearly going uphill from left to right. It's positive. Flip them all over and rationalize. Flip it over. When you rationalize it, you get this. Flip it over and rationalize it, you get that. And those are our answers. You guys should be able to flip and rationalize on your own. Okay, what if we're given a point? Try to use, well, no, it's 11. I am not going to use the graph paper. This is not to scale. Don't worry about the graph paper. There is a mysterious point at 11, -2. So write a lot, down a little, right? Let's pretend this is the point 11, -2. You still connect it to 0, 0. Make it a right triangle touching the x-axis. Theta between the x-axis and the hypotenuse. That's a little tiny theta in case you can't see it. And I need to label the sides. So if that's the point 11, -2, it's right 11, down 2. Pythagorean theorem to get x, your hypotenuse. Hypotenuse squared equals leg squared plus leg squared. Square root of 125. Too bad it's not the cube root, right? I could cube root that, but I can't square root it, so I'm going to leave it. Write it on my hypotenuse. And answer the question. It wants all 6 trig functions. Let's see if you can write your trig functions in partners. I'm going to pause my video, and when you unpause it, you're just going to see the answer blanks written next to each other in partners. Okay, hopefully you were able to partner those up correctly. From theta, sine, opposite over hypotenuse, -2 over root 125. Is this on the unit circle? If I go 11 to the right, am I still on the unit circle? No, it's not a root 3 or a root 2, so do not rationalize it. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Flip them over. As long as you partnered them up right, you should be able to just flip them over to get the reciprocal trig answer. There you go. Last one. See if you can draw it correctly and label it correctly. Not to scale, obviously, right? But this is approximately -2 root 3, comma -8. Make it a triangle connected to 0, 0. Connected to the x-axis. Theta between the x-axis and the hypotenuse. This must be -2 root 3 because it's the x value. This must be -8. Pythagorean theorem to get your hypotenuse. Okay, expect to see this a lot. Negative 8 squared is clearly 64, and I don't have any issues thinking you can do that on your own. Negative 2 root 3 squared. Obviously the negatives go away. Let's just get rid of it right now. When you square that, you square the 2 and you square the root 3. Root 3 squared is regular 3. And now you need to multiply those together. So it's plus 12. I don't know. 3 root 7. What is that squared? 3 squared is 9. Root 7 squared is 7. That's 63. Make sure you understand how to square mixed numbers like that. Okay, 64 plus 12, 76. X is equal to the square root of 76. It's the hypotenuse, so I don't need to worry about it being negative. Write your answer blanks and see if you can name all 6 trig functions. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. I got rid of the negatives because they crossed out. This one does reduce, and potentially on the multiple choice it might be written like this instead. So make sure you know those are the same. I don't care how you write it on your test. Flip it over. Flip it over. Oh, where'd my root go? You guys didn't tell me I was missing the root on the cosine. Sorry about that. The negative is just in front. It doesn't matter if it's on the top, on the bottom, or just in front of the entire fraction. Okay, hopefully this helps you find trig of any angle, whether it's on the unit circle or not. Hope you guys are doing good.